right, guys, let's knock this review out. Number 1 says 3 to the 2x is 26. Is first 6 or 7, just solving the equations. So what I'm going to do here is I'm going to do log of both sides, put the exponent in the front. Natural log 3 is natural log 26. Divide, I forgot to put the natural log on the left-hand side. That's a great start to the video. Sorry about that. Natural log 26. So I'm going to go natural log 26. Man, you know, just go ahead and turn this off. Over natural log 3, and punch it in my calculator. I'm getting 2.9656. Just going to divide that by 2 to get my final answer. I'm looking at 1.4828, but we're going 4 decimal places on these. Number 2, doozy, because I have exponent on each side. Remember what that means. Exponent goes in the front, natural log 7. Exponent goes in the front. And remember on these also, if you want to use log, L-O-G, that is absolutely fine too. I'm just being, a tad bit lazy because ln only has 2 letters and log has 3. That's pretty sad. Okay, put the x's together. So I got x natural log 7 minus x natural log 9. That equals negative natural log 9. Factor out the x on the left-hand side. That leaves natural log 7 minus natural log 9. Hint, hint, that's subtraction. Remember when you see subtraction, we turn it into division. So it's really x natural log 7/9 equals natural log 9. So I'm going to divide both sides by the natural log of 7/9 to get my final answer on my calculator. When I punch that in, I'm getting 8.7429. Make sure you're getting the same thing there. Let's go to 3. 3, you got a factor. So I'm going to say e to the x and e to the x. Because if you multiply those, you add the exponents, it would give you e to the 2x. Factor is going to be minus 2 and minus 1, which means e to the x is 2. E to the x is 1, because we have to make the parentheses 0. So I'm going to do natural log each side. If I do natural log over here, obviously I just get x. Same thing over here, natural log over here, I just get x. So my answer on this first one is just whatever the natural log of 2 is. So a bunch of natural log 2, getting 0.6931. Over here, natural log 1, don't have to punch that in, that's 0. Those are my 2 answers for number 3. Number 4, it's only one log. Anytime there's one log, you do the log, which means I can take that base e to that power equals x. So x equals e to the 5.4 power. You can just punch that in real quick. E to the 5.4, easier for me to say. E. I'm going to punch it in, 221.4064. It's a pretty quick one there. Number 5, same deal. There's only one log. If there's only one log, I'm going to say that base to the 5th power equals x minus 4. So I'm going x minus 4 equals 2 to the 5th power. Everybody knows 2 to the 5th power is 32. Move the 4 over. That's 36. Check your answer. Make sure it doesn't make the log negative. It does not. We're in good shape. Keep going. Number 6. I've got 2 logs on the left-hand side that are added together, which means I'm going to use multiplication to combine them. Getting x squared plus x. Over here we've got log 20. Because you have one log on each side, you can just drop the logs. X squared plus x is 20. Move the 20 over so we can factor that thing. And the factors of 20 are 5 and 4, so I get x plus 5x minus 4. Just about 2 answers would be negative 5 and 4 maybe, but you need to plug them back in. Negative 5 is not going to work in the first one because that's going to make that log negative, so that's out. 4 is really good, so 4 works perfectly. So there's the first 6. Number 7, another one like we just did. This is almost exactly the same. I have 2 logs added together, so when I have 2 logs added together, I'm going to, in this case, do FOIL. So I'm going to get x squared minus 2x minus 15 when I do FOIL there. Now, because I have one log, same step, this base to that power equals that. 9 to the first power is 9. It's going to equal x squared minus 2x minus 15. I'm going to move the 9 over to join the 15, makes it 24. So I got to find factors of 24 that give me negative 2, which is 6 and 4. Let's choose my answers are 6 and negative 4. Maybe negative 4 won't work here or here. It's out. 6 looks good both places, so there's my solution. It's x equals 6. Number 8. Suppose you invest $55,000 in an account that pays 6% interest compounded monthly. How long will it take for it to double? Okay, so if you double $55,000, you're going to get $110,000. So over here, I'm going to put $110,000. That's what I end up with. Okay, beginning with 55,000, 1 plus r, which is 0.06 over n, which is 12. Remember, 12t power. It's asking me for how long it will take, so I'm looking for the time. First step there is divide by 55,000, which is going to be 2 over there. Also going to punch in the parentheses exactly what that is inside my parentheses. And when I do that, I'm getting my parentheses alone is 1.005 to the 12t power. And again, to try to find the exponent, I'm going to do log or natural log both sides and do natural log 2. Exponent in the front over here, natural log 1.005. I'm going to divide both sides. I got to come over here. I'm out of room. 12t is going to equal, I'm going to divide by natural log 1.005. So I'm punching in natural log 2 divided by natural log 1.005. I'm getting 138.975. That's too many decimal places because, well, it's not, I'm talking about time. And divide that by 12. When I divide that by 12, I'm getting 11.6 years for it to double. Not bad. Making $55,000 in 11 years doing nothing. Number 9. Under ideal conditions, certain bacteria doubles every 6 hours. Initially, there are 500 bacteria. And here's our function right there. Part A says find a model. That is the model. You just got to fill in the stuff you know. N sub 0 means initial amount, which is 500. 2, I'm going to put 2 here. And then T over A. A stands for, A is the doubling time. So I'm going to put T over, and it doubles every 6 hours, so T over 6. That's part A. That's the model. Part B, how many are there after 12 hours? So all I'm going to do for that is I'm really just putting in 12. N of 12 is 500 times 2. 12 over 6, which is really the second power. So I'm punching in 500 times 2 squared, which is 4. I'm going to have 2,000 there. I could do that part in my head. 2,000 bacteria. And then part C, when will it reach 8,000? So it means the 8,000 is what you're going to end up with over here. It starts with 500, 2. Don't know the time. That's what it's asking me for. And there you have it. So I'm going to divide both sides by 500 first. So I'm going to have 2. Over here, I'm going to have this left. If I do 8,000 divided by 500, I end up with 16. And so do log both sides. ln 16 equals t over 6 ln 2. I'm going to divide both sides by natural log 2. So I'm doing natural log 16 divided by natural log 2 on my calculator. I'm getting 4. So just multiply both sides by 6. You get 24 hours for it to get to 8,000. Number 10, another similar kind of problem. The initial bacterium count. A lot of bacteria today. In the culture is 1,000. Biologist later makes a sample count of bacteria and finds that it has a relative rate of growth of 50% per hour. So it's percent growth this time instead of doubling. So another function. So part A says find a function. A function, it tells you what to do. N sub 0 is the initial amount, which is 1,000. E, the rate is growing, is 50% times T. Okay, and there's your model. Part B, how much is there after 20 hours? So I'm just going to plug 20 in for the T, 1,000, E, 0.5, 50 times 20. Let's just punch that in real quick. 1,000 times E to the 0.5 times 20, which is 10, by the way. And I'm getting this right here, 22,000, sorry about that. 26465. Good night, that's a lot. I'm not going to round that. So it's 22 million bacteria, not that big a deal there. It's huge. Okay, when will it reach 40,000? How long will it take to reach 40,000? So 40,000 was to end up with, starting with 1,000 over here, E to the 0.50 T. First step is divide by 1,000. 40,000 divided by 1,000 should be 40, which it is. E. Now, because this is E, you have to use ln this time. Natural log 40. Exponent goes in the front. Remember, if you do natural log of E, it's out of here. So my final answer is going to be whatever natural log 40 is, divided by 0.5 or 0.50. I'm getting 7.4 hours for it to get to 40,000. That's a fast growing bacterium. All right, let's keep going. All right, stay with me on this one. Number 11, 2 ways to do this one. And part of it you're going to have a choice on, part of it you're not. So hang in there with me as we go through this one. First one, it says polonium 210 has a half-life of 140 days. Suppose the sample has a substance of mass of 600. That's the initial. And here's our function right here. I'm double checking to make sure. Yeah, that looks good. So it says find a function that models, and there's two ways to do this one. And this is one in part A. So then we're going to do that one first. So part A, find the model. So I'm doing MT equals the initial amount, which was 600, times 2 to the negative T over H. And H is the half-life. And it gives me the half-life is 140 days. So it'd be negative T divided by 140. And there's the first model. All right, part B tries to get you a little bit different way, the other model. So I'm going to do MT, initial amount is still 600. E is negative R over T. Now, I don't know what T is. That's going to be down here. Negative R. The way you find R is always this formula. You do natural log 2 over H, which is the half-life. So I'm going to do natural log 2, punching here, natural log 2 divided by the half-life. The half-life was 140. I'm getting 0.005. So I'm going to go negative 0.005 because the formula has a negative sign. So that's part A and B. Now when it says part C here, it says find the mass remaining after 1 year. It's your choice which one you want to use. It makes no difference. I'm going to use the first one. I don't really know why, but I'm just going to use that one. So 1 year, so I'm going to say, okay, after 1 year, I'm doing 600 times 2 to the negative 1 over 140th power. Just going to punch that straight in my calculator. Okay, the video cut off right there. I'm not sure what happened, so if you missed some of that, I'm sorry. So I'm going to go ahead here. I'm going to do natural log each side, which means the exponent is going in the front. So basically what's going to happen, I'm out of room here. If I do, I'll punch it in. Natural log 1/6 is going to give me negative 1.7918. And it's going to equal negative T over 140. So to get my final answer, I'm going to multiply both sides by negative 140. That takes care of the negative sign and the 140. So I get, it should be 250.8. I don't know if that was grams, milligrams. I can't see it. Let me pull it back down real quick. Here's milligrams. Left after, well, that's how long, oh, sorry, that's how long it's going to take. 250 years or days. Golly bum. I could read 250 days, almost 251 days to get there. Sorry about that. I had some technical difficulties and had some Mr. Brown difficulties. Number 12, graph this, take the domain range. You got to do your own little graph here. Didn't provide you a graph for some reason. First of all, +2 means it's been shifted left 2. This means your asymptote is 2 to the left. It's over here. Remember, we always put a point 1 to the right there. My next goal is to make this be the same as the base. If the base is 3, I need that to be 3, so I'm going to put a 1 in. Remember, x is 1. If x is 1, which is right there, I'm going to go up to 1, which is there. Connect the dots. So there's your graph. Your domain, how far left and right is going? It's going from -2 to forever. The range, how far up and down is it going? Up and down forever. The asymptote is at x equals, and it's x equals because it's vertical. X equals -2. All right. Hopefully, other than the shaky start there, and also number 11 when I hit the wrong buttons, and also went crazy for a minute. That's a good review. Come see me in the morning if you need to, or whenever tomorrow before your test. Hope you do great. I'm sure you will. See you. Bye.